For the AI project, I have chosen to compare rule-based systems with Unity's ML agents on how they go around a racetrack. For the setup of the racetrack, I created 2D sprites which had box colliders and rigid body components for the walls. These are also triggers and are tagged with the wall tag for collision responses in the AI scripts. Reward gates were also made so that the AI can track its progress. They also have box colliders and rigid bodies. Each one has a checkpoint script which gives each reward gate an ID number. They are also tagged with the reward gate tag for collision responses in the AI scripts. Moving on to how the rule-based system works. Multiple rays are created which are used to determine whether the car should turn left or right and whether it should move forwards. The car also has a rigid body component and box collider so it can hit the walls and reward gates. The car is attached to a game object called start line so that when it hits a wall it just goes to where the start line is positioned. The car has two scripts attached. One contains all the rules for the car and the other controls movement. In the car movement script, multiple float variables are created. The steering and acceleration power control how fast the car can move. The steering amount and speed are created for using the input, which will be explained later on. Direction is used for rotating the car. The start function gets the rigid body component as this is needed for adding force and rotating the car. The fixed update function calculates the direction by figuring out the dot product of the car's velocity and up vector. The car's rotation is then calculated by multiplying the steering amount and power, the velocity magnitude and direction. The car has forces applied in order to make it go forward. The first force applies the car's up vector multiplied by the speed. The second force applies the car's negative right vector multiplied by the velocity's magnitude and steering amount divided by 2. The set inputs function is called in the car RBS script and car agent script. This is where the speed is calculated by multiplying the forward value passed in and the acceleration power. The steering amount is also assigned here to the turn value passed in. Moving on to the car RBS script. The variables needed for the script are the game object that stores all the reward gates, the length of the rays which are cast forwards from the car, as well as the length for the rays casted sideways. Lastly, it needs a reference to the movement script. The start function receives the movement script as well as defining the forward ray length and side ray length. The update function stores the rule base. Firstly, two float variables are declared. These get passed into the movement's set input function at the end of update. The angles for the forward left and right ray are calculated by linearly interpolating the car's up vector with the right vector using the appropriate weighting value. These values are then used for the ray cast for each ray. The straightforward ray checks if it has hit a reward gate or the finish line. The finish line being the last reward gate. If so, then it moves towards it. The forward left and right rays check whether they have hit a wall or not. If they have, then they tell the movement script to steer away from it. The side rays also have the same functionality as the forward left and right rays. The steering and forward float values are then passed into the movement script using the set input function. Lastly, the script has a function which deals with its collisions. If it has hit a wall, then it moves back to the start line and rotates it. The checkpoints are also set to being active again. If it has hit a reward gate, then it sets the reward gate to no longer be active. If it hits the finish line, then every reward gate is set to being active again. That's more or less it for the rule-based system. Moving on to the ML agent. The ML agent has two ray perception sensor components which control what the car sees. A decision requester is also added which tells how often the AI should make a decision every academy step. The behavior parameters control the actions the AI takes as well as adding in the neural network models. The car for the ML agent also has the movement script attached as well as its agent script. The ML agent script inherits off of Unity's agent class. This gives it access to the AI-specific functions in Unity. The script needs the game object which stores all the reward gates as well as the current ID of the reward gate it needs to get to. The movement script and rigid body are also required for this script. In the start function, the rigid body and movement script is received. The agent has 4 specific functions which have a different role. The onEpisodeBegin function sets the target checkpoint to be the one at the start of the racetrack as well as setting the car's velocity to be 0. The collectObservations function tells the sensors to add the target reward gate's position, the car's position and velocity to the AI's observations. The function also adds a small negative reward to the AI. This is to make the AI find the fastest way to go around the track. The onActionReceived function tells what action the AI should do. If the AI has chosen to use the third option in its available actions, then the value is turned into -1 so that when it is passed into the setInputs function it does what it is expected. The heuristic function is for manual human input for if you are using imitation learning or testing the movement of the car. Lastly, the car agent script also has a function which deals with collisions. If the car has hit a wall, then a negative reward is added to the agent. The car is also set to be at the start of the racetrack and the episode is ended. The checkpoints are also all set to being active again. If the car hits a reward gate, then the script checks whether this is the right checkpoint. If so, then it gives the AI a reward as well as incrementing the ID of the reward gate the AI now needs to go to. The script also sets the reward gate to no longer be active. If the car hits a finish line, then the script does the same thing as the reward gate response but adds a more significant reward as it has made it through the whole racetrack. It also sets all the reward gates to be active again and the target reward gate ID to be 0. That is everything in this project. Thanks for listening. Just before the video ends, here is some gameplay of the comparison between how the rule-based system goes around the track compared to the ML agent.